If we reverse this expansion like rewinding a movie, we reach a point where everything converges to a single location, a moment of infinite density and temperature called a singularity. In this episode, we're diving into one of the most mind-bending questions in all of science, and the answers might completely reshape how you think about reality itself. Have you ever stared up at the night sky and wondered what existed before everything began? Before the first star ignited, before space itself expanded, before time started ticking? Today, we're diving into one of the most mind-bending questions in all of science, and the answers might completely reshape how you think about reality itself. Picture this moment. 13.8 billion years ago, everything you see around you, every atom in your body, every galaxy stretching across the cosmos, was compressed into a point smaller than a grain of sand. Actually, forget the grain of sand. We're talking about something infinitely smaller than anything you can imagine. This was the Big Bang, the moment when our universe exploded into existence. But here's what keeps physicists awake at night. What was happening before that moment? For decades, scientists told us this question was meaningless. They said time itself began with the Big Bang. So asking what came before is like asking what color Wednesday tastes like. But recent discoveries in quantum physics and cosmology are suggesting something revolutionary, that maybe, just maybe, our Big Bang wasn't the beginning of everything after all. But wait, there's an even stranger possibility emerging from string theory, the idea of the multiverse. But here's where things get weird. Our current physics completely breaks down at this singularity. Einstein's general relativity, which beautifully describes gravity and space-time, gives us mathematical nonsense when we try to describe this moment. We get infinities everywhere, which in physics usually means we're missing something important. It's like our best scientific theories are holding up a sign that says, sorry, we don't know what happens here. This breakdown has led some scientists to propose that the Big Bang wasn't actually the beginning, but rather a transition from something else. Think of it like a bouncing ball. When you see a ball at the peak of its bounce, you don't assume it magically appeared there. You know it was thrown up from below. Could our expanding universe be similar, the result of something that came before? One fascinating possibility is the cyclic universe model. Imagine the universe as breathing, expanding, and contracting in an endless cycle. In this scenario, our Big Bang was actually a big bounce, the moment when a previous contracting universe reached maximum compression and then rebounded outward. This previous universe might have looked completely different from ours, with different physical laws, different types of matter, maybe even different dimensions of space and time. Some versions of this theory suggest these cycles have been happening forever, an eternal sequence of cosmic death and rebirth. Another mind-bending concept comes from quantum mechanics, the idea that our Big Bang might have emerged from quantum fluctuations in a pre-existing space. Picture blowing soap bubbles. Each bubble represents a separate universe with its own Big Bang, its own physical laws, its own story. In this view, asking what came before our Big Bang is like asking what other bubbles exist in the bath. The mathematics of string theory suggests there could be an enormous number of possible universes, each with different values for fundamental constants like the strength of gravity or the mass of electrons. Most of these universes would be completely hostile to life as we know it. In some, atoms couldn't form. In others, stars would burn out too quickly or never ignite at all. We happen to live in one of the rare universes where the conditions are just right for complexity and consciousness to emerge. If you're captivated by these mind-bending possibilities of cosmic existence, consider hitting that subscribe button and joining us for more explorations into the universe's deepest mysteries. At the moment of the Big Bang, our conventional understanding of time simply doesn't apply. Even perfect vacuum is seething with activity, particles constantly popping in and out of existence in tiny fractions of a second. These quantum fluctuations are not just theoretical. They've been measured in laboratories, and their effects observed in the cosmic microwave background radiation left over from the early universe. Some physicists propose that our entire universe began as one of these quantum fluctuations, but instead of disappearing almost immediately like most virtual particles do, it inflated rapidly through a process called cosmic inflation. In less than a trillionth of a trillionth of a trillionth of a second, a region smaller than a proton expanded to the size of a basketball. This inflationary period would have smoothed out any irregularities and set the stage for the more gradual expansion we observe today. But this raises another puzzle. What caused inflation to begin, and what caused it to end in our region of space while potentially continuing elsewhere? Some models suggest inflation is eternal, constantly creating new pocket universes like ours. These aren't just academic puzzles. They touch on fundamental questions about the nature of reality, consciousness, and our place in the cosmos. In this view, asking what happened before time existed is indeed meaningless, like asking what's colder than absolute zero. The question assumes something, the existence of time, that might not have been there to begin with. However, other approaches to quantum gravity suggest that time might be more fundamental than we thought. In these models, time could continue flowing even through what we perceive as the Big Bang singularity, connecting our universe to whatever came before. The challenge is that we currently have no direct way to test these ideas, no method to peer beyond the cosmic microwave background radiation to see what might have preceded our cosmic beginning. Recent developments in gravitational wave astronomy are opening new windows into the early universe. When massive objects accelerate through space-time, they create ripples called gravitational waves. Advanced detectors like LIGO have already spotted waves from colliding black holes and neutron stars. Perhaps the most humbling realization is how much we still don't understand. Dark matter and dark energy make up 95% of our universe, yet we have no idea what they actually are. Our best theories predict that the universe should have collapsed long ago or expanded so fast that no structures could form. Yet here we are, contemplating our own existence on a planet orbiting a star in a galaxy that shouldn't exist according to our current understanding. The question of what came before the Big Bang pushes us to the very limits of scientific knowledge and human comprehension. Whether the answer involves cyclic universes, quantum fluctuations, multiversal bubbles, or something else entirely, one thing is certain: the journey of discovery is far from over. Every new telescope, every particle accelerator experiment, every theoretical breakthrough brings us closer to understanding not just what came before our cosmic beginning, but what it means to exist in this vast, mysterious, and beautiful universe we call home. What do you think came before the Big Bang? Share your thoughts in the comments below, and don't forget to subscribe for more mind-bending explorations of the deepest mysteries in science and philosophy. If you've been awestruck by the profound questions of what came before the Big Bang, make sure to subscribe for more incredible journeys through the cosmos. And to continue your exploration of the universe's wonders, click on the video appearing on your screen right now.